want me to rewrite the things, just
Yes,
let me
ma'am.
know. All right.
Okay. Yes, ma'am.
So see, whenever the particles of the medium vibrate about their mean positions at right angle, if this is a wave, this wave is formed by the particles. All the particles that are aligned together, these ultimately form the wave. So whenever these particles are moving about their mean position at right angles, mean in a direction perpendicular to the direction of propagation, then that type of wave that we get, those waves are known as the transverse wave. And see, whenever the particles of the medium move back and forth about their mean position, like if this is the mean position, these are the particles, these are moving back, and then these are moving ahead of themselves. Then again, all of these are moving backwards, then again back and forth. So this kind of wave that we get, whenever the particles are moving back and forth about their mean position along the direction of propagation of wave, then we say that is known as the longitudinal wave. So in case of transverse wave, we get crest and trough. This
True.
above
Yes.
bulged portion is the crest, positive part, and the negative downwards portion is the trough. Whereas in case of longitudinal waves, we get rarefactions and compressions. Wherever you see all the particles are clustered together, these portions are the compression.
Compressions.
And these will be then the
Rarefactions.
rarefactions. So do you know what is this distance? This makes one wave, either a crest or a trough together, or we can say mid of this crest to the mid of another crest, or mid of this trough to another trough.
True.
Or simply we can say one crest and one trough. This makes a single wave. All right.
Yes,
So if
ma'am.
this is a single wave, so what should be this distance? Length of the wave, right?
Yeah.
So that makes it the wavelength. So wavelength is basically the distance traveled by the wave during the time any particle medium completes one vibration or cycle about their mean position.
Mean position.
Okay.
Yes.
Now see, similar is case of the longitudinal. We'll be dealing with the transverse waves basically. But regarding the longitudinal waves also, either the consecutive distance between the rarefactions or the compression will be the single wave, that is the wavelength. Now see, these are all the various particles as I've told you. All these particles are vibrating like this about their mean position. And what we see, a continuous wave like this. But in actuality, all these particles, this is not a single particle. These are various particles which are moving and forming this wave. So what happens if I say this is the mean position? So if you look at all these particles, are you able to notice that this particle is at the highest position?
Yes.
Yes. So
Yeah.
this distance, this maximum displacement that has occurred from the mean position, this is known as the amplitude. Amplitude. Now see, we have two terms. We have time period and we have frequency with us.
Yes.
One time period means that whatever time is taken to complete this one cycle, this one wavelength, what we see. Whenever this one vibration or this one cycle is completed, whatever be the time, but what the condition should remain is that it should be one cycle, one vibration only, one cycle, one wavelength. Whatever the time comes, then we say that is the time period.
Time period.
Whereas if I say in 1 second, how many waves are able to travel, then that becomes the
frequency.
Okay.
Yes.
And then this is wave velocity is a very simple term, which means the distance covered by wave in 1 second. Basically, the velocity that you have studied in motion in 1D, distance per unit time, or you can say rate of change of distance is what? That gives you speed. Rate of change of displacement gives you velocity.
Velocity.
So similarly, in those cases, in case of motion in straight line, we refer to objects. Whereas in case of this wave, it becomes the wave velocity. It's just specific velocity for the wave. So these are the basic wave terminology that we should remember before big. Understood?
Yes. Yes.
Okay, now see.
Ma'am, can you scroll up? I'll take the screenshot.
Okay. You take the screenshot.
Yeah, done, ma'am. You can scroll down.
So see, simple harmonic wave or harmonic wave is what? That will be dealing in detail in oscillation.
Yes.
That
Yes.
is
Yeah.
given in all simple harmonic motion and
Yes,
multiple
ma'am.
case. But just a very brief one. How do we represent a harmonic wave? So what is SHM? That is none of your concern right now. With that we'll deal later. But see, how do we represent this wave? The simple basic representation of a harmonic wave is the particle displacement. You should remember this because velocity, acceleration, all the terms are related to displacement ultimately. So you should remember how do we represent a wave. So that is given by A sine kx plus minus omega t plus phi naught. Now see, A is this amplitude of the wave. Amplitude of the wave means the maximum displacement that is covered by the particle from where? Equilibrium or mean position.
Yeah, equilibrium. Yes.
Mean position. Then sine is simple sine of sine and cosine that we take. K is a constant and this is related to wavelength through this relation. K is equal to 2 pi divided by lambda. All right. So wherever you have to convert either wavelength into K or K into wavelength, you can use this relation. And then X is the displacement. X is again the displacement whichever will be mentioned to you. For example, like the question will be asking you find out the displacement of the particle at x equals to 3 meter or something. So you have to insert the value of whatever is the displacement covered, that is x. Then see plus minus. You have to be careful when it will be plus, when it will be minus. Now see, if the wave travels, this is my x-axis, positive x-axis, and this is my negative x-axis.
Okay.
So if the wave travels in positive x-axis,
so it will plus.
It will be minus.
Oh, it will minus. Okay.
Okay, so it will be reciprocal of it. Ulta kar dena.
Okay.
If the wave travels in positive x direction, you will write the equation as y is equal to a sine kx minus omega.
Minus omega
And
t.
if it's minus x, then means negative x-axis.
Plus
then
omega t.
Plus omega t.
Yes.
Just reverse it.
Okay.
And omega is the angular frequency.
Yes.
That you are already aware of. T is time. Just this thing comes that is known as the phase constant. Phase constant means whatever angle the wave has been shifted by from the direction of propagation. If I say this is the direction of propagation, in this direction the wave is propagating and the wave is moving like this. So this is an angle, it's making an angle with the propagation direction. So we say that is known as the phase constant, which is describing as the phase of the wave. If I say there are two waves, let's say there are two waves. This is one is this yellow wave and another one is this red wave. So phase constant between these waves means what? Means the angle between these waves. That is from this plane to this plane. Whatever is the angle being created, that is known as the phase constant. So many a times what happens, if two waves are in the same phase, then we'll be writing phi naught as 0. This phase constant will be eliminated. So ultimately you will be left with y is equal to a sine kx or plus minus whatever is there, omega t. You can write it as 0. So we'll be looking at cases where phi naught will be equal to 0, where phi naught will not be equal to 0. So is this basic clear how to represent a harmonic wave?
Yes, ma'am.
Okay, just note it down. Then we'll do particle acceleration. Just a second. Scroll it a bit.
Ma'am, you can scroll down. Just note it down.
You have written it?
Yeah. I was there.
Okay.
I wrote it.
See, this is what? This is the displacement of the particle of the harmonic wave. Now see, from displacement, can you tell me how is velocity calculated from displacement?
Velocity from displacement.
Yes. Try to recall your chapter motion in 1D. There you must have done a lot of questions on this. When displacement is given, a variable displacement is given. And how do we calculate velocity?
Mom.
Okay, see, what is the relation between displacement and velocity? In general, very basic, just try to recall it. Velocity is basically what? Rate of change of displacement.
Yeah, change of rate displacement.
Rate of change. So what is the formula for velocity? Just try to recall your previous chapters. In the first term, you must have done this. Velocity is given by displacement upon
X
time.
by, yeah.
X by t.
X by t.
If the displacement is variable,
dx by dt.
dx by
dt.
Okay, this
Yes.
differentiation gives us the velocity.
Yes, ma'am. Yes.
Yes?
No. Yeah,
Okay.
yeah.
One
No,
more
yeah.
thing. If you have the velocity and if I want to calculate the acceleration, are you able to remember this relation between these two?
Ma'am, there was a derivation for this.
Acceleration will be differentiation.
Yeah, dv by dt.
dv by dt.
Yeah,
Right.
dv by dt.
dv by dt. So if you have x with you, means you have displacement with you.
Yeah.
So if we have displacement with us, which is variable, so with differentiation, with using the differentiation tool, will we be able to calculate the velocity and acceleration?
Yes, ma'am.
Yes.
Yeah.
So see, this is the particle's displacement. Regarding the particle velocity and particle acceleration, see, since we are deficit of time because your exams are ahead, so that's why I'm using all the derivation that have been written already. So I'm again telling you, wherever you want me to repeat or rewrite the thing, just let me know.
Yes, ma'am.
All right.
Yes,
Nothing,
ma'am.
because this will save our time ultimately. See, when I have to calculate the velocity, and I've written for positive x direction, this will be minus kx. For positive x direction,
yeah, minus k.
Minus kx. It will be reverse of it. We'll be writing minus.
Yes.
So see, velocity will be given by what? If this is the displacement equation, then velocity will be differentiation of this displacement only. dy over dt.
dy by dt.
When we will be differentiating this, yes, this particle velocity will come out to be omega a cos omega t
minus kx.
Okay. One more thing, in oscillation that we'll discuss also, velocity is given by this relation. V is equal to omega a. This is the maximum velocity. And how do we get it from the mean position and extreme position? That is written over here. Just ignore this part. Just look at this part. Omega a is the maximum velocity and minimum velocity is 0. We'll see how will it come. But just for now, remember, if omega is the maximum velocity, so the particle velocity, this particle velocity can be written as V max cos omega t minus kx. All right. And V is equal to omega a is 2 pi t. See, omega is what? Angular frequency.
Angular frequency.
2 pi mu.
2 pi and 2 pi.
What is this?
None the formula. No, it's not formula.
Linear frequency. This
linear frequency.
Linear frequency. And this frequency is inversely proportional to time. So omega becomes 2 pi by capital T also. So these two are the formulae for the angular velocity. So V max can also be written as 2 pi a by t. So see, a is what? Can you tell me what is this a in this equation? This a.
A is amplitude, right?
Amplitude, right, correct. A is the amplitude. Since we are differentiating it, and amplitude will remain constant. So that's why we say it's the velocity. Similarly, now I have the velocity with me and I wish to calculate the acceleration of this particle. So simply I can differentiate it. Acceleration will be what? Differentiation of velocity that will provide me the particle's acceleration. So see, whenever we differentiate, what happens? The constant term comes out. So omega is the constant term that will come out again. And see, differentiation of cos gives us sine, but with a negative sign. whenever we are differentiating sign, we get a plus cos, means a positive cos. When we are differentiating cos, we get negative sign. And this just gets reversed in case of integration. So that's a difference. So acceleration's formula ultimately comes out to be minus omega square a sine omega
t minus k
minus k.
minus k.
Here I am considering that there is no phase constant, there is no phase difference. Wherever the phase difference is there, you have to include. If I say a particular wave leads another wave by 90 degrees, so I'll be adding this plus pi by 2 means 90 degree in this equation. So don't forget that we have a phi naught also with us, the phase constant. All right.
Yes, ma'am.
So this is the particles. Okay, I have all the solution with me only. See, this is question, just a very basic example. Y is equal to xt 0.05 sine pi by 2 10x minus 40t minus pi by 4. Okay, one thing, just tell me what is this?
Ma'am, the
0.5.
That's the angle?
Not the angle. What was the cosine?
Amplitude.
Right. So if you are given this equation and if you're asked what is the amplitude of this equation, so you'll simply say 0.05 and you will see the unit. Here it is written meter, so the amplitude will be what? 0.05
meters.
Now see, in this pi by 2 is being multiplied with this 10x as well as with this 40t. So what should we do? We should just multiply this pi by 2 with this so that we get the equation. So this will
pi
be
by 2 into 10.
Pi by 2 into 10x minus pi by 2 into 40t. We're just opening the bracket. So this will be y is equal to 0.05 sine 5 pi x minus 20 pi t minus pi by 4. So see, in this equation, you are right. This is the amplitude. Okay, just tell me what is this?
Is that kx, right?
K, yes.
Kx. Yeah, k.
So this will be k and this is the x displacement. And what is this?
20. Ma'am, that's angular frequency.
Angular frequency. Yes, you are right. Angular velocity, that we write 20 pi omega t. And what is this pi by 4?
Pi by 4.
One more term that was there in the standard equation of harmonic motion.
Ma'am, there was TO, right?
Phi naught.
Yeah, sorry, pi naught.
That symbol that we write, this
symbol
with a diagonal sign, this is the phi naught. This is known as the phi. This symbol is known as phi, and since we put a 0 in the subscript, that's why we call it as phi naught. So many a times, mainly after theta or apart from theta, wherever we have to represent angle, we use this term usually, but it can be used in any way. So see, this is the phase constant, the phase difference between
phase constant.
Okay, now look at this equation again and tell me, in which direction is this wave moving?
Ma'am, the positive. No,
positive.
Sorry.
Positive, right. See,
positive, right.
Kx minus omega t. So this wave is moving in the positive x-axis. All right.
Yes.
Now see, this is the displacement provided to you. If it asks you what is the particle's velocity at x equals to 0.5 meters, the weight is given over here. See what you will do. You have the displacement which you simply differentiate it. That will give you the velocity. And in the final answer, you will be getting in terms of x and t only, because these are variable quantities. On differentiating, these will be left. So just put the value of x and just put the value of t wherever required. If you get such kind of questions, and if you are asked acceleration even, then whatever value or the equation of velocity you are getting, just differentiate it one more, because acceleration is what? It is double differential of the displacement. So you'll differentiate it again and put the values of x and t and see whatever is the acceleration. So you will be able to manage all these questions?
Yes, ma'am.
Okay, so just take this, let me know from where have you are you having the notes with you, or you wish to take the screenshot of this? Just let me know.
Ma'am, I'll just take the screenshot now.
Okay, if you wish to note it down, just let me know. I'll stop also.
Okay,
Whatever.
ma'am. So, ma'am, can I write this?
Yes, yes, of course. You can
Okay,
write this.
ma'am, I'll just write it. One
Okay,
minute, ma'am.
okay. Just take your time. Write it down. When you are done, let me know. I'll scroll it further. And just don't write this part. I was just explaining something that time. Just don't write this part. This we'll do in the oscillation.
Ma'am, can you scroll it down? Okay. Done, ma'am.
Just note down this question and you can do this. You can write this and try this question later. Just note it down until.
Okay. Okay. Done, ma'am.
All right, fine. So see, rest of the questions you'll be getting in this manner. This intensity is part of your entrances. This is important. This question is important, and this is very, very easy. But this is a question that usually comes. See, remember, there are two types of velocities. One velocity will be the velocity with which the wave will be traveling. This velocity of this particular wave with which it is traveling. That we say is the velocity, wave velocity. But see, if I talk about the individual particles of the wave is obviously made up of this energy, all the particles that we call the wave. So if I talk about the particular energy of one particle, then I say that velocity of this particle gives us the particle velocity. So wave velocity is different and particle velocity is different. And
So,
yes, ask if you.
no, so for formula of particle velocity is omega by A.
Not omega by A, omega multiplied by A.
Yeah, sorry, omega multiplied by. Sorry, ma'am.
Okay,
Yeah.
and the formula for wave velocity is omega by K. And see, these are the maximum values of them. And see, this particle velocity we have in detail in oscillations also. So we will be calculating how do we get this omega A. But just for now, remember the maximum particle velocity is omega A. A is the amplitude. And maximum wave velocity is omega divided by K. So many a times I've seen this question. This question comes. This equation is given to you and it says what is the ratio of maximum particle velocity or maximum wave velocity. Otherwise it comes calculate the maximum particle velocity. So just remember those two, these two formula for particle velocity and for the wave velocity.
Yes, ma'am.
It will be what? Omega A divided by omega by K.
Yes.
So omega तो cancel हो जाएगा, क्या बचेगा ultimately? A multiplied by A.
K.
अच्छा, अब अगर ये equation है आपकी, just look at this. In this equation, what will be your amplitude if you compare it with the standard equation?
What will be my amplitude? If I compare my standard.
See, I've written the standard equation already. This is the displacement that is given.
So 10, right?
10 meters. It will be 10 meters. और ये क्वेश्चन आता है एग्जाम में कि सिर्फ इक्वेशन दे दिया जाएगा तुमसे सब बेसिक चीजें पूछी जाएगी एंगुलर फ्रीक्वेंसी बताओ amplitude. So you should be able to identify what are all the parts of this standard equation. Okay, one more thing. What is the value of K if you look at this equation?
K 1200. Right?
That is omega T, remember.
Oh yeah, K is 3.
Okay.
K is 3. Kx, yeah.
Yes,
omega T, Kx.
So this will be 3. So this will be Ka. So this will be 3 into 10. That will give you 30. Easy?
Okay. Yes, ma'am.
Okay, just note it down. This also.
Done, ma'am.
All right. So see, next topic, that is interference. I'm skipping it because interference is part of your entrances from 11th point of view. Now it has been deleted, I think. Interference you'll be dealing in detail in 12th, interference diffraction, when you will be studying wave optics. What is important for you is the stationary waves, the standing waves. So see, let us understand what is meant by this. What is the meaning of these stationary waves and how are these standing waveforms? In general, whenever you see two waves, and if these two waves have the same wavelength and the amplitude is also same, amplitude is same, wavelength is same, and the speed is same, just the difference comes in the direction. Everything remains same, but the waves moves in opposite direction. And then they superimpose each other. So the resulting wave that you will be getting, that single combined wave because of the superposition of these two waves, that wave that we get ultimately, that is known as the standing wave, or this is also known as the stationary waves. The reason that these waves are called stationary waves, because there is no transfer of energy along the wave.
Okay.
Reason is simple. The particles at the nodes do not move at all. See, this position of maximum displacement, that was amplitude. This is also known as antinodes point, wherever the displacement is maximum, and wherever the displacement is zero, like these points that I have highlighted with blue, these ones. See, here the particle is at the mean position only, so there the displacement will from the mean position will be zero, right?
Yes. Yes, ma'am.
These points are known as nodes, and wherever the displacement is maximum, those points are known as antinodes. So a reason that these are called stationary waves is that the particles at the nodes do not move at all. So what happens? All the energy cannot be transmitted across them. So that's why, since there is no transfer of energy, we say that these waves are stationary waves. Just simple reason. So there are points known as nodes where the value of displacement is zero, and these points are known as the antinodes, where the maximum displacement value is there. All right?
Yeah. Yes, ma'am.
Okay. Now see, the equation of stationary waves is a bit different and a modified version of the simple harmonic wave that we have seen. So see, the derivation that is there, this is very simple. But before beginning this, what is this derivation? You have to understand one thing. See, this principle is very, very, very important, because this principle, superposition principle, this will be coming in all your chapters of 12th standard also. This is a very general principle that can be applied in rest of the topics also, rest of the properties and rest of the physical quantities also. See, specifically, I'll tell you for waves right now. Whenever you have n number of waves, let's say I have this wave which displacement is y1. Okay, so displacement is a scalar quantity or a vector quantity?
Displacement is a
Vector quantity. So
vector,
that's
right?
why I'm drawing these arrows to represent the vector quantity. Okay, let's say we have another wave y2. y2 is the displacement of this second wave. Let's say I have another wave y3 is the displacement of this wave, and so on. I have n number of waves. Yn, I have n number of waves. Now see, if I want to know if all of these waves will combine together, if all these waves, whenever two or more progressive waves can travel simultaneously in a medium without affecting the motion of each other, if they do not affect the motion of each other, we say we'll get a resultant displacement. Definitely.
Yes, ma'am.
Okay. So see, resultant displacement of each particle of the medium at any instant, this is that resultant displacement that we'll be getting. That is the vector sum of all the individual displacement. So if I have y1 with me, I'll be adding y2, I'll be adding y3. But what kind of addition is this? This is not simple algebraic addition. This is the vector addition. So you must have done vector laws, triangle law, parallelogram law,
Yes, ma'am.
modular.
Yeah.
Mainly parallelogram law gets applied wherever there is requirement of it. Otherwise, you can simply add it whenever the angle is 180 degree or 0 degree, the way you have been using your basic vectors. So on till the nth wave. So if there are 5 waves, I'll be adding y1 plus y2 plus y3 plus y4 plus y5 vectorically, whatever
Yes.
is the angle I'll be considering. So this basic principle is known as the superposition principle. See, when you'll be going in 12th, you'll be dealing with electric field. So there also, if different electric fields are there, like E1, E2, E3, E4. So you will be adding them vectorically. That will be the superposition for electric field. Similarly, for if you say forces, you will be adding all the vector forces vectorically. Then that is known as the superposition principle. So regarding the waves, when two or more waves pass through the same medium at the same time, the net displacement at any point, this is equal to the vector sum of the individual displacements at that time. So the superposition principle is clear to you?
Yes, yes, ma'am.
Any doubts till now?
Ma'am, is there a definition for it?
Let me write it down. I'll write down the principle.
Yeah, principle.
And see, remember that there is no derivation for this. This is just a general principle which can be applied to various vector quantities.
Okay.
So since we are dealing with waves, so I'll be writing particularly for waves. When you will be going in your 12th, you will be dealing different quantities. So see, when two or more waves pass through the same medium, at the same time, the net displacement at any point is the vector sum of their individual displacements. At that perspective or that particular. This is the definition, basic definition of superposition principle.
Ma'am, 1 minute now. I'll write this.
Sure, I'm saying.
Done, ma'am.
Fine. So see, if this is just the basic principle. Now see, regarding stationary waves. You see, when I'm talking about stationary waves, as I've told you, this is not a single wave. This
Yes,
is
ma'am.
actually combination or
Of
superposition
waves.
of two waves, right? So here we have to deal with superposition principle. So see, if there's a rigid boundary, just look at this. If there's a rigid boundary like this one, and there's an incident wave as well as there's a reflected wave, means this is the same wave that gets reflected because of this rigid boundary. So incident waves equation will be, if I say this is moving in this positive x direction, in this direction, so the equation will be a sine omega t minus kx.
Yes, minus kx.
Minus kx. And see, reflected, if it is getting reflected, this is moving in negative x direction.
Plus kx.
Plus kx. So these two will be the equations for the incident wave as well
and
as
the reflected wave.
reflected. Fine.
Yes,
Now see, since stationary, in case of stationary waves, what happens? One wave is moving in this direction, the other wave is moving in the opposite direction. So see, since rest of the quantities are same, amplitude is same, the frequency is same, what is just the difference comes in the direction.
Yes, ma'am.
I'll be using superposition principle, means my resultant displacement will be the addition of these vectorially. If I add the individual displacements of this incident and reflected wave, right?
Yes,
is this valid? Can I write it like this?
Yes, ma'am. Ma'am, what is YR?
YR resultant. YR.
Oh, result. Yes.
The resultant displacement. this is reflected.
Yes,
Just
sir.
don't check it. The
Yes,
resultant wave. Alright. Now see, if I add these two, since this is making an angle of 0°, you can say these two waves are making an angle of 180° actually. These are moving into opposite direction. So simply, whenever you will be even putting it in parallelogram law and adding it vectorically, ultimately you will be left with this one. YR will be YI plus YR. These kind of questions I think you have already dealt in motion in 1D, motion in plane, when you must have been dealing with parallelogram law, all the various angles if two vectors are given, right? Laws of
ma'am.
motion में भी तो कितना आया था force पे.
Yes, ma'am.
See, if I add these two, this will be a sin omega t minus kx plus this term a sin omega t plus
Plus
kx.
kx.
So see, 2a cos kx, 2a cos kx sin omega t. This
Equation
is
of
the
standing wave.
ultimate equation of standing wave.
Standing wave.
There are various, actually what happens, we use different identities, trigonometric identities, so that will take a lot of time. What you should remember right now is that y is equal to 2a cos kx sin omega t. Now see, whenever I say what, just look at this, just look at this equation, this equation. Now see, this term, this is the extra term, sin omega t is similar to the previous one.
Yes, ma'am.
So whenever I write this equation, like I was writing it, y sin omega t minus kx and rest of the term, what was the amplitude in this?
A.
A. So what all term was coming before sine, you have considered it as amplitude, right?
Yes, ma'am. Yes,
If I
ma'am.
say 2 pi sin omega t minus kx, so what will be the amplitude in this?
2 pi.
2 pi. If I say this is my equation of standing wave, what according to you should be the amplitude?
Amplitude. Amplitude comes before sine. So
Yeah, yes. So it should be
should it be kx?
not kx only. All the term that comes.
Oh
with
yeah, all the terms. Yes,
So
all the
that will
terms.
be
Yeah,
what?
yeah.
That will be what?
2a cos kx.
Cos kx. So
Yes.
the amplitude of standing waves becomes simple, 2a cos kx. Clear?
Yes, ma'am.
Okay. And see, nodes and antinodes, I've told you, points of maximum displacement and zero displacement. But see, you should know the position of nodes and antinodes. The definition remains same, that amplitude wherever it is zero, that is known as the
Note.
node. And wherever the amplitude is maximum, we say
It will be antinode.
antinode. Now see, regarding nodes and antinodes, you should know these two. Okay, see, when I am considering the node, I'm just trying to figure out what should be the position of node. If I want to calculate where are the nodes exactly located on the waves. So see, if the amplitudes equation is this, 2a cos kx, points of zero amplitude is known as the node. Points of zero amplitude are known as the nodes. So this is the amplitude, this is the node, this is the amplitude. Actually, I have written it as R because just to show that this is the resultant amplitude and to differentiate it with the main amplitude. Otherwise, this is also amplitude and this is also amplitude. Yes, that's what you have seen 2a cos kx right now. Now see, in this, if I am talking about node, then my amplitude will be what? 0?
0.
0. So see, this whole term 2a cos kx, this whole term becomes 0.
0.
Now see, at what angle do we get cos theta 0? See, this 2a will get divided by this 0. This will also be 0, means cos kx will also be 0. And cos kx means what? Cos kx is some angle that is 0. Means cos theta is 0.
Is equal to 0. Theta is equal to
yes, when theta is
0, right?
no 90 degrees.
Oh yeah, 90.
And cos 0 degree is 1. Okay, cos 90 is 0 and cos 0 is 1. Just this is a reciprocal, it is reverse of sine. Sine 90 is not 0. Sine 90 is 1 and sine 0 is 0. Okay. So see, if I say theta will be 90. So see, kx means here we didn't have theta. What was the angle? Kx was the angle. No,
Yes.
angle यहाँ पर तो kx था. So if this means that this kx is coming out to be 90. Theta तो कुछ है ही नहीं. Theta तो ऐसे हम लोग ने ले लिया है. Simplify समझने के लिए कि ये था क्या. Ultimately, this kx is coming out to be 90 degree, right?
Yes, sir.
It means kx is equal to pi by 2. अब देखो एक चीज है, cos सिर्फ 90 पे 0 नहीं होता. Whenever you will be writing cos 3 pi by 2, that is also 0. Cos 5 pi by 2, that is also 0.
0.
So we have written all the values of 0 whenever we can get cos 0. If I'm writing cos is 0, this means I'm getting amplitude as 0. And if amplitude is 0, this means the position of will be of the node. So see, if you write the value of k, you will be getting, just to simplify it, you can write it as 2n minus 1 pi by 2. अब n की जो वैल्यूज पुट करते जाओगे वैसे वैसे kx की ये वैल्यू मिलती जाएगी. जैसे n1 पुट करो, क्या हो जाएगा? 2 minus 1 हो जाएगा 1 into pi by 2 हो जाएगा pi by 2. So यही होता है, 90 डिग्री तो होता है हमारे पास. kx is equal to 90 डिग्री जो हम लोग ने लिखा था. इसी तरह से if you put it as n is equal to 2, then you will be getting 2 into 2 is 4. 4 minus 1 is 3 pi by 2. So if you take any value of n, just multiply it. This is the result. This is a standard way of writing it. So whenever you have to find out the position of node, you can write it in this manner. X will be equal to 2n minus 1 lambda divided by 4. How I have got this lambda? By using this relation. K is what? 2 pi by lambda. So if I write 2 pi by lambda from over this side, so this pi will cancel this pi. 2 will be multiplied by 2 and lambda will go. X will be equal to 2n minus 1 lambda by 4. Is this part clear?
Yes.
Okay. So if you
Ma'am,
have
this is a formula, right?
This is the formula. This becomes the formula for position
of node.
Node.
Okay.
So if you have to calculate for the first node, where is the first node located? What is the position of the first node? Just put n is equal to 1. That means this will be what? 2 into
1 minus 1.
1. That is 1 only. 2 into 2 into 1 minus 1 is 1 only. This means lambda by 4. That is, if I have this wave with me, this is 1 lambda. This whole is 1 lambda, means this is the whole wavelength. So if I divide it into 4 parts, lambda by 4 means this part only. This is the position of my first node. This is just an example. What is meant by this? So if you wish to calculate position of second node, you tell me what should be the position of second node.
Position of second node. So instead of n, we'll put 2, right?
N will put 2. So that will be
2 into 2, 4, 3.
Yes, 2 into 2, 4. 4 minus 1, 3.
4 minus 1, 3. Yeah.
3 lambda by 4. So,
3 lambda.
So you have all the values with you now. X equal to lambda by 4, 3 lambda by 4, 5 lambda by 4, and so on. You will be able to identify the position of nodes. Similarly, now we have seen this in detail. Whenever you have to find out for the antinodes, what was antinode? Points of maximum displacement.
Maximum amplitude.
So everything will remain the same. It's just that instead of getting 0, we'll be getting the maximum value. And see, for cos theta, the maximum value that is possible is 1. Beyond 1, you don't have any value. You have not seen any value of angle where you can say cos theta is equal to 3.
Yes.
Or the value of cos is 2 even. Maximum value is what? 1. So see, that's why we say 2a cos kx. That this will be equal to plus 1. That is the maximum value. And see, the way we have 2n minus 1 pi by 2 for the zeros 1, means for the nodes case. You can summarize this as n lambda. So just put all the values of n. Like if you put 0, kx will come out to be 0. If you put n is equal to 1, kx will come out to be pi. So you know, cos 180 value, this is minus 1. And see, maximum value means maximum value doesn't only mean this plus 1. -1 also gets included in this. Because see, mid value is what? Mid value is 0. This is the minimum value. Rest values are above and below this. So we say these are the maximum values. Then you have cos 2 pi. Cos 2 pi means 360 degrees. That is +1 again. So this +1, -1, +1, -1 cycle will go on as you will keep on increasing the value of n. So now see, if you put kx is equal to n pi, and if I write k's value as 2 pi by lambda, pi will get cancelled. Now this formula, this is the position of antinodes or nodes?
Antinode, right?
Antinodes. So if you have to find out the position of antinodes, you can simply write it as n lambda by 2. So see, different values of wavelength you'll be getting. Like in the previous case, in case of nodes, we were getting what? Lambda by 4, 3 lambda by 4, 5 lambda by 4, and so on. In case of antinodes, first you'll get the first antinode at x equal to 0. Then if you put it as n equal to 1, you'll be getting it at lambda by 2, then at lambda, then at 3 lambda by 2, then 2 lambda, and so on you can continue. So are these location of antinodes and nodes clear?
Yes, ma'am. Ma'am, can you just scroll up for the node formula? 1 minute. Okay.
So
They
have
are
you
done.
done the previous part?
Yes, ma'am. I have.
Okay.
I wrote till this reflected ray and incident ray result.
You have it. Okay, from here?
Yeah, I have written.
Okay. From here you have to write.
Yes, ma'am.
Okay, just write it.
Done, ma'am. Yeah, ma'am, I wrote this part, like node formula and all those things.
Okay. Nodes you have written for.
Yeah, and I wrote the antinode formula also.
You have written it here. This is complete.
Yeah, this is completed.
Okay, fine. So see, okay, this is also a question of your syllabus only. Okay, see, this we have discussed frequency, amplitude, wavelength. If you have to calculate, will you be able to identify?
Yeah.
Fine. This we have done.
Amplitude is 6 here.
Amplitude will be 6 always. These are for your inferences. Okay, fine. See, time is up today. Are you free tomorrow at the same time?
Mama, actually, I already gave a message like today and Saturday I'm free. Friday is
Saturday?
yeah, Saturday and Saturday, Sunday I'm free.
Okay. Then I think we'll continue the at this time is fine. 7?
Yeah. Like 4:30 to 5:30 for my time.
Okay. So after 5:30 you are free.
After 5:30?
You are available for the class?
Ma'am, 5:30 like Indian time or the here's time?
Indian time.
Indian time, yeah. Here, yeah, I'm here available now.
Okay.
So, ma'am, this time is okay, right? 4:30 to 5:30.
Yes, this time.
Okay.
This is fine. This time is fine for you?
Yeah, it's fine.